Hello and welcome back. Okay, over the course of the extended project I've been making with the CPU and all the peripheral components to it, one of my favourite little almost standalone circuits is actually the controller reading circuit. And I'm going to be looking at that today with an aim to converting it into a PCB so I can incorporate it as a module into the final build. So let's take a look at the breadboard version and then take a look at the schematic and PCB work. Okay, so this is a simple two breadboard circuit. It's mostly the counters, demultiplexing, and a couple of 541 line drivers. Let's see if we can get this going. We've got the bus tester circuit here, which should be useful. I'm going to get rid of that longer cable. Use this shorter one I've made up. The main bus goes in there simply. And this is the device connector, so we've just got the power, and it's only the assert line that we use. Well, I'm going to connect both up. Normally this board would be powered from there, but obviously the power lines are all cross-connected, so I think I can plug this in anywhere. This lovely set of LEDs shows us when the buttons are pushed. And then if I use the assert line, I should be able to toggle between the two halves and see the same bit patterns being pushed onto the bus. Nice. Okay, designing a PCB for this, we don't need the clock chip as we're intending to use a single clock chip on the peripheral board and distribute that across the various circuits. So let's take a look at the schematic and start turning this into a final PCB. Okay, I had a little bit of a look around here before I started recording, and it looks like I've got all of the key circuit elements in apart from the decoupling caps. So I'm quite grateful to past James for actually finishing this off well. Now before we can start doing the layout, I do need an understanding of the shape it needs to fit into on the back plane. Now this is the audio controller that is the last piece of PCB work I designed, so it's going to want to go beside that. These are the initialization inputs. I shouldn't leave them floating. I'm going to hook those up there. I don't think there's any need to use them, but there's going to be some uninitialized inputs, and I think it makes sense to actually have those cross-connected. And the unused gates there need to be cleaned up. I think some of the extra peripherals that aren't controllers use those lines on the SNES, but we're not concerned with those. So this is the height it needs to be. I'm going to be cheeky and grab those as well. Because if I line these up exactly with the other versions, it's going to make it easier to route the back plane. But this is the actual SNES connector, and that's going to be the important bit for sizing the board. The height's fixed, we can be as wide as we need, but we must be wide enough to fit this port on. So I'm going to need at least 2 squares either side to fit it in. And it needs to be 5 squares from the lower edge, so it hangs over correctly. So that is the minimum size the PCB can be. With any luck, we'll be able to keep it inside that. It's a simple pull-up resistor, so the input line isn't a floating connection if we don't have a controller plugged in. I definitely think it's worth having the extra support here if we're going to be plugging something in and out. Wasn't expecting any 1UF ones. I do think it would be very, very cool to get the LEDs, rather than stick them in numerical row, put them in the pattern of how they are on the controller. Okay, start and select the other way around. Don't have a lot of room for this. How close are we to being able to fit this in? Bring it all in a bit tighter. Feels really cramped, but it would be cool. I mean, I think that looks really cool. And I can see I'm going to have a horrible time routing this. Want some labels on it. Okay, well, I think I need to take a stab at routing this. All of the signals down here are going to be very difficult, but this will be a 4-layer board. Let's see how it goes. All right, let's see if I can give myself a bit more room up here. These signals are going to be really difficult. And as usual, when I'm routing this stuff initially, I'm going to hide power and ground. I'm expecting this to be a 4-layer board. I'm making my life very difficult putting these LEDs here in this pattern, and I'm wondering if this might be the time when, just to justify that, I switch to a 6-layer board. Okay, I don't know how far down I can pull these. I start and select. Gives me a bit more room. If I can fit 2 wires in the gap between LED pads, that's going to make this a lot easier. Right, so I think that's the lines to the LEDs connected. We've still got a bunch of signal wires and control lines. I can route this quite directly on the back of the board, but I'm worried I'm creating a bit of a blocker on the PCB layout there. Right, now the signal lines are going to be a pain, but no worse than what we've dealt with already. Does that keep switching layers? Oh, I see, it thinks I was trying to click on that pad. I think with these ones I'm going to have to come round these wires. I could make these shorter hops, or 2 short hops on the back plane with short red stints on the front plane, but it's not actually going to reduce the overall complexity anything. Basically, I need to try and make these bus lines interfere with everything else as little as possible. I kind of feel like these are the most difficult remaining lines. Right, there are no rat lines down here. We've still got power and ground to do, but those are nowhere near as difficult as what we've already done, because we've got planes of power and ground in a 4-layer board. Gee, I've got more room upwards. May as well use it. Actually, doesn't feel like there's a massive number of lines left. This bit with the lines running in the same direction is a problem. That is all the rat lines done, all the signal and data lines. And we turn power and ground rat lines back on. All internal planes default to ground regardless of what you name them. You have to then select the layer and change it there. Okay, so that's telling me no DRC errors, which is fantastic. So now we just need to see if we can pretty this up a bit. All right, so that's the space where it needs to go. Compared to a lot of the other modules, the connections that this thing needs is very limited. This device need a clock and the bus. Other pins here just to improve the stability, especially when we're plugging stuff in and out. Yeah, I need a title and stuff on here. This JLC bit is where the PCB manufacturer is going to stick their serial number. And if I put it there, it's going to be underneath the SNES connector and nice and invisible. Now looking at this now, if I wasn't so concerned about limiting the width, I could have made that ever so slightly wider, moved these 2 chips up into this gap, and then had lots more space. But I'm totally happy with what we have here. I could ground fill on the front and back as usual. Don't know when they moved, but that could have been quite awkward. Right, I think that is a good looking board that's going to be very fun to put together. Okay, so now I want to create a temporary backplane for it. Now, when I made the audio controller temporary backplane, I suddenly had the idea afterwards that if I'd done this, I'd have made my life a lot easier. So if I just stick pin sockets on here to accept a crystal, I can avoid needing a second little breadboard. I'm going to put 2 copies of that on here, which might seem weird, but because both the audio controller and the SNES controller use device 9, if I put them both on there like that, I can daisy chain the connection if I need to, and it costs me absolutely nothing to have the extra 4 holes drilled. These are wrapped differently than normal. Going to be a nice little PCB though, isn't it? Right, let's get a board out and let's get some paste on here. I was thinking that was a coincidence that it's the same width there, but of course this was previously used for the sound controller and that fits into the same height slot, so that shouldn't be a surprise. Should do. It's very difficult to estimate exactly how much paste you need. There's always the risk that you squeeze some around, although solder paste tends to be quite forgiving in that regard, so I think it's going to be okay. Probably need a little bit extra here. Right, so that's the pull-up on the input. It might actually be worth me putting pull-ups onto the control lines coming in from the device pins, or indeed any control inputs, just because we don't want a non-connected circuit, if powered, to have floating lines. Okay, so that's the capacitors. Now these resistor arrays are going to be difficult. The 0603 resistor arrays are absolutely tiny, quite a challenge for my shaky hands. I think it would actually be easier to do regular components 0603 and then use 08 resistor arrays. Now we have to be very careful about the polarity and direction of these. So we've got the tiny little T shape. It tells us which way it needs to go. So I think the thing to do is rotate the board and fit the ones that are in the correct orientation. For these last two, I'll turn them around. 0603 LEDs would have fit here easier, but I didn't want to change the size of LEDs I was using midway through the build. 541 line drivers. '04 inverters. Didn't like the way the legs only just touch the pads there. So there are two different sizes of these chips which seem to have the same code. Fortunately I had both sizes in, but I do need to double check which pads I had. So when I was hand soldering these it was very troubling. I think it would have probably been okay, but since we've got the right chip, may as well use it. Right, so the 193s are of course counter chips. If I was designing this circuit for mass production, which you would never do these days, you'd use a microcontroller, but if I was, I would not use up-down counter chips. I was influenced here by having lots of these lying around, because they're the counter chips I use in my address registers. Alright, I think that's all close enough. Need to get the hot plate set up and let's reflow this. Right, let's have a look. The resistor arrays look okay at first glance. Okay, there's a couple of pins on the inverters that look slightly questionable. That ground pin looked dubious, but it looks absolutely fine when I tilt it. This is why the high-end labs have a stereoscopic microscope, give you a bit of depth perception. We need some pins on these. I will use the tested technique of stacking these up in some of the old PCBs. And this should drop on top easily. I've got this lovely overhead light in this room now, and it makes it very easy for me to get good light on what I'm seeing. But because I stuck it straight over where the cameras are, it's not doing me any favours there. I might need to rethink that a little bit. And of course the most important bit here is the SNES connector. The pins on these are very slightly mobile, so I kind of have to get them right. Now they are an extremely close fit. I was worried for a second the holes on the PCB were too small. That's pretty. I need the backplane componentry so we can actually test it out. That ground pin is more about support than electrical connection. It's just the one that was notably off. These are not going to be easy to do. Because I've got 2 copies of the device 9 stuff here, so I can daisy chain the connections on. Though just looking at that, I can see I've made a mistake. I've left the load line not connected, because of course this PCB didn't need it. Ah, that's a mistake. It's only a temporary backplane though, so it's not that big a deal. I don't feel all that bad about a temporary backplane bodge. I'm actually hoping that this temporary backplane won't be in use for very long. Awesome to get all of the peripherals together on one big backplane. I think I didn't solder that. Right, let's see if we can test this. Right, so from this board we do need to extract the clock. Well, I could use just about any clock, I think, as long as it's not too fast. Connect the main bus up. Actually, might be an idea to do that with a longer cable. No, I'm wrong. A short one would be better. Okay, get power in up the top here. No smoke at least. Okay, now I've made a mistake there, but this is all working well. But when I went through and labelled these lines, I've obviously got them slightly wrong. Ah, that's really frustrating. How did I mess that up? It's Y and B are the wrong way around. And then the right doesn't work. Alright, let's investigate that. Okay, unfortunately I wasn't prepared for a big troubleshooting session and I didn't have enough available space on my camera. I do have the soldering footage, so I'm going to cut some of that into this discussion. Now the first thing I did was go through and test the assert line for all the buttons, and that works. So everything was fully operational. We did spot that these 2 buttons were reversed and the start and select button was reversed, and then I was left with the right shoulder button's LED not illuminating. Now I fixed that now. My first fault though was that the resistor connection in the bottom left here, which is wired to this, wasn't making good contact, so I resolved that. I don't actually know if that made any difference whatsoever, but then rather embarrassingly I moved on and discovered that the LED here was on the wrong way round. So I eventually cut this off, removed the solder from the pads and put a fresh new LED on. And now it works. So the only problem we have is 2 pairs of LEDs are the wrong way round. Now they both come from this bottom right resistor array. So I think what we need to do now is go back into the schematic, fix that, and then patch the PCB design. I really don't want to leave it like that, so let's just start the process of fixing it right now. Okay, so a big question is, will it be better to reroute the buttons after the resistors or before? So start and select the wrong way round. Okay, that would be absolutely trivial to do here. And then Y and B are the wrong way. So I've got both the pairs wrong on this resistor. Interesting. I mean, that looks fairly straightforward as well. Start off with the shame. What will that do if I update it? Okay, so I've renamed the nets to swap them over, and I deleted the LEDs, renamed them in the schematic, re-imported them, and then repositioned them. Now, that looks correct, but I've got a suspicion I've left a tiny little piece of wire underneath here as well that's going to cause a problem. Right, so start and select weren't too bad. Y and B look too easy, like I haven't swapped them over. That's what I was expecting. So the wires are misattributed now. That ends easy. That was pretty easy as well. Okay, so that's the wiring fixed up, and fortunately without having to make any drastic changes to the PCB. I did create this image though. That's about twice what it needs to be. Is that going to be okay, or are they going to try and print that on the copper? Makes it all slightly more interesting. Right, let's get that ordered. Now I'm hoping I can assemble this quicker second time round. The only easy way to tell the difference is just the version number and the extra little lines we put round to show the controller shape, but I do like that change. Now in theory, this should be exact still. Looks it. Maybe a little bit low on that. It's a shame because those pads were really crisp otherwise. Excellent. Have to watch that one carefully. Right, need to be super careful here because I made a mistake last time. Now these LEDs look physically very slightly different than the ones I had last time, but it was a new pack. More of an arrow under these. So you can see there's a distinct shape difference inside the LED. And I'm just making sure that all lines up. I think that's right. Just cleaned the tweezer tips a bit. I'm hoping that's going to make my life slightly easier here. Apparently not. Okay, well let's get the hot plate out and try soldering it. Okay, first impression there is good. That is everything, so I don't think there's any real reason to delay giving it a test. Right, so that's the old board with the buttons the wrong way around. Right, so up, down, left, right shoulder, select, start, B, Y, A, X. Fantastic. Right, so let's hold down A and B. So just trying to give you a good view of the bus LEDs here. Okay, I don't like that. What's happened there? Oh, hang on. I pulled the power lines out there. Okay, that had me worried for a second. So B and Y, that looks correct. A and X. That feels like it's all working. I think the only thing left to do is to get the CPU build out and actually integrate this back in and make sure it still works there. Okay, here's the CPU build. I've got the UART attached, and that's the only other peripheral because we use this for communicating with the system. But I think I'm going to reconfigure this slightly. One of the big advantages of having a standardized bus here that I've got the connectors for on both sides is I can move the boards around as to how it suits for any particular piece of work. Now this bus connection is easy because I put several of those in, and it's device 9. Okay, so that continues to function while we're plugged into the build. The actual process of asserting data onto the bus, we pretty much tested that using the bus tester. So I'm expecting this is going to work. Now this first bit of code just decodes the buttons after constantly reading them. It's left, right, up, down, start, select, B, Y, X, A. It should display combinations of them as well. That's awesome. This is such a simple circuit, but I'm really pleased to have it, particularly since it lets me do input with very minimal additional componentry and very simple code to read the data in as well. Try for something a little bit more fun. This is SNEC, my little snake clone. Now this is outputting via the serial port to a serial terminal. And this was obviously the first game that I got working. Awesome. Okay, this game's quite special to me, but the serial terminal output, that's got to go for the long term. We've got a whole VJ circuit now, so I think this is probably the last time that I will show you the serial port version of that, and the next time I show you SNEC, it will be outputting to the VGA. I think that's pretty much ready, but I think we've proven that the controller is in brilliant working order there. I'm incredibly pleased we got that fully working. Now, this would have actually done exactly the same thing, but the cosmetic difference on the LEDs here was going to haunt me if I didn't fix it. And after I first started assembling this, I had the idea that maybe this extra outline here to highlight the controller and help identify where the buttons and the LEDs matched up was going to be a nice idea. So I was kind of quite pleased in one small way that I got to remake this PCB. But job done. I'm really happy. Awesome. This is probably the biggest gap I've had between the introduction and the end segment recording, but in the end we got it all working. It was only really a cosmetic issue apart from the mistake putting the LED on the wrong way round, but the original PCB was pretty good, but I needed to get the LED arrangements to match the buttons correctly. As it was, I think we finished with an awesome little board that's going to look really nice in the final system when it's all put together on a unified set of backplanes. I hope you found this interesting, certainly fun and challenging for me. As always, thanks to my patrons, I really appreciate the support, and I'm looking forward to seeing you again soon. Goodbye.